Okay, today we are solving quadratic equations by the completing the squares technique. Now there are many techniques to solve quadratic equations. Well, we could use the quadratic formula, or we could actually try and factor. But today we are going to always, we're going to use the completing the squares technique, but whenever we see x squared plus bx, we are always going to replace it by the completed square, which is x plus b on 2. Now obviously if it was a minus, it would be a minus. Then this is always minus b on 2 or squared. Okay, we always subtract off. So what do you do? Well, you look for the x squared plus bx. Now the b is obviously the coefficient of the x, so you halve that, you complete the square in here, and always subtract. Even if that was a negative b on 2, this is always going to be minus b on 2 squared. So this bit will always be negative. The reason being that you create too much when you complete the square. Okay. Now, let's look at an example. Here we have a simple example. Let's just move the 5 across. X squared plus 6x equals 5. And you can see here, we just go half the 6, x plus half of 6 is 3 squared. Now we always subtract this one. Remember, 3 squared is equal to 5. Now, you can see here we have what? Well, minus 9 and 5 are 14. So we go x plus 3 all squared. When we move that across, we get 14. Then we have, well, crikey, this is x plus 3. Now remember, put a plus and a minus, square root 14 when we take the square root of both sides. And then we just move the 3 across, x equals minus 3 plus or minus the square root of 14. Now, we could work this out correct to so many decimal places using the calculator, but at this stage, that's in the exact form. So x is, obviously you can see here, there are two solutions. X equals minus 3 plus the square root of 14, and x equals minus 3 minus the square root of 14. So these are the two, if you like, solutions to the quadratic equation. They basically where the quadratic function will cross or cut the x-axis. Sometimes they're called zeros or roots of the quadratic equation. Okay, let's look at another one. Now, you can see here, this one now has a coefficient of x squared. We need to, first of all, isolate x squared minus bx. So we need to take out the 3. This one's not too bad. Put the 16 across on the other side. And you can see here we have x squared minus 4x is now equal to 16 on 3. Now, so we've isolated the x squared minus bx, and we complete the square now. So we go x minus 2, half of the negative 4. Squared, always subtract the 2 squared, is equal to 16 on 3. Now, minus 4 and 6, well, 3 into 16 goes 5 and a third. So if we now move that across, we have x minus 2 all squared is equal to 4 and 5 and a third, 9 and a third. Therefore, x is equal to, you can see here, well, put the 2 across as well, plus or minus the square root of 9 and 1/3. Now, I did a few steps there. This will now give us the solutions x equals 2 plus the square root of 9 and a third, and then also x is equal to 2 minus the square root of 9 and a third. Again, the two solutions to the quadratic equation. These are the zeros or roots. We could roughly round them off to 2 decimal places, or whatever, how many decimal places we needed to. Now, let's try an example where the coefficient won't come out very efficiently. So here we go. Okay, so let's take the 5 out. X squared, now it's minus 12 on 5x. Let's put the 4 across, minus 4. Let's divide by 5 now to isolate the x squared minus b on x, or bx, which is now the x squared minus 12 on 5x. Now minus 4 on 5. Now, we now have to halve minus 12 on 5. Now, hopefully everyone knows a half of 12 on 5. We can see that this 2's will cancel. Hopefully it's 6 on 5. Okay, so we can see that half of 12 on 5 is actually 6 on 5. So we end up getting x minus 6 on 5 all squared. Now, minus 6 on 5 all squared is equal to minus 4 on 5. Now, 6 on 5 squared is 36 on 25, so we can move that across. Let's get x minus 6 on 5 square is equal to minus 4 and 5. Now we have a plus, moving it across, 36 on 25. Now minus 4/5 is actually 4 5s are 20, so it's minus 20 25ths, and this would end up getting x minus, or leaving, is equal to what? That's 16 on 25. Now, okay. Now when we take the square root of both sides, we end up getting that x minus 6 on 5 is equal to plus or minus the square root of 16 on 25. That works out quite nicely, which is 4 on 5. So we end up x equals 6 on 5, moving the 6 and 5 across, plus or minus 4 on 5. That gives us what? X is equal to what? 10 on 5, and minus, oh no, it's actually positive. It's actually 6 minus 4 is 2. So the answers are x is equal to 2, and the other one 2/5. Okay. Well, we'll leave it there for the time being. Thank you for watching.